So, hi to all, welcome back again for the cybersecurity subjects. Okay, so in today's class, in Unit 3, Secure Communication, I'm going to cover the topics cryptographic trust models and cryptographic key pair. So, in the last class, we have seen about the introduction to encryption and cryptography. What are the various cryptographic functions like CA triad, that is confidentiality, integrity, availability, non-repudiation, authenticity we have seen, and we have seen about the symmetric and asymmetric types of cryptography. In today's class, we are going to see about cryptographic trust models and cryptographic key pair. So what is basically cryptographic system trust model? So in the cryptographic scenario or in the schema, there are a number of methods that's used to assure that the person you are communicating with is really the authorized party. So with that only we have seen the various cryptographic functions, right? So apart from that, there are various other methods are there. What are they? There are three methods are there. The first one is web of trust, second is Kerberos, and third is certification authority. It is a very famous, very authenticated, widely used methods for ensuring that the person we are communicating with is really the authorized party. So the first one is web of trust concept, which used in pretty good privacy, PGP. Very famous protocol is PGP, pretty good privacy, and in other open PGP compatible systems also this web of trust concept is used. Second, Kerberos is a distributed authentication service designed to provide strong authentication for client server. Whenever we say Kerberos, means the keyword associated with that is client server applications. It will be working in a distributed manner by using the secret key cryptography. And the third is the certification authority, that is the third party entity that issues a digital certificate to authenticate the user's ownership of a public key. So these are the three methods we will be seeing in detail one by one. So the first one is web of trust. So as I told already, web of trust is used in pretty good privacy and other compatible systems to establish a trusted relationship between a public key and its owner. So let us go back and try to understand what is a public key. In asymmetric key cryptography, there are two types of keys. One is the public key and the private key, right? So I gave an example also for that. Suppose we go to the bank locker, we have two keys. One, the key is with us, that is a private key, because the bank locker has two keys, right? Two locks basically. That is the reason two keys. One with us, that's the private key, and one with the bank itself, that becomes the public key. So how to establish a trust relationship between the public key and its owner? How to do that? For that case only we have this web of trust. So when we have a bank logger, first we should offer bank account, and then we have to go for a bank logger, and that is how we create the trust there, right? Similarly, in web of trust also certain steps are there. So it is basically a decentralized security model in which participants authenticate the identities of other users. So it is similar to a social networking website. How does it work? For example, if you take Facebook or LinkedIn, suppose if you log into your Facebook, you can just see your list of friends, right? Via your friends. For example, your friend will be a friend of others. Their names also will be listed to you. So there is actually a security or a kind of known person authentication is there. So even if you go to bank to open a previously, not nowadays, previously to open a bank account, we have to actually go through a reference, but nowadays that has been changed, right? So previously that was a scenario. So like that only in your social networking websites also, friends list will be there. Via friends versus friends, that list will be shown to us. Based on that, we will accept the friends of them and then include into our domain, right? Include into our website. So this is what a simple concept of a web of trust. So for example, if Susan trusts Niha, then Susan could also trust the public key of Rita, who does not know if this key has been authenticated by Nihat or not. But since Susan trusts Nihat, so Nihat's friend is Rita, in that way it goes. We trust the persons and start including into our profile. Whereas Kerberos, so in the first case, it is totally, if you could see, it is decentralized web of trust. Whereas Kerberos is a networking authentication protocol based on the client server architecture, right? It's a centralized one, opposite of your web of trust. It works in the client server architecture by using the secret cryptography. So it provides secure authentication between the user and server rather than host to host. The main component of a Kerberos schema is the central server, because central server is where the key all will be stored right? Or a trusted third-party server, either a central server or trusted third-party server where the keys will be stored. Is used for authenticate all the request, and then only the keys will be served to the requester. So in this network, each connected host has its own secret key, and one of these hosts is the central Kerberos server, which is a key distribution center. So here afterwards, when KDC is referred to as key distribution center. So all host secret keys will be stored in the key distribution server. So in some networks, not all the host keys will be stored in central key, whereas central KDC, whereas the group of systems that are under the same master is called, it will be stored. So it differs some case, but predominantly KDC will store all the keys. That's what is the scenario. So it provides secure communication by checking each connected host secret key with one stored in it. Compare and then only it will allow. So after a client server have been using the Kerberos to assure their identities, they can begin to exchange the encrypted data. So before exchanging the data via the KDC, the client and the server will first check the identities, and then only encrypted data will cross the unsecured network such as the internet. But the main disadvantage of Kerberos is that user credentials are stored on a central KDC server. So if a malicious hacker gains access to the central server, then entire Kerberos authentication system is at risk of being compromised. The third is the certificate authorities. So these authorities issue digital certificates for websites, online services, IoT devices, and individuals. For example, all your degree certificates after you complete, right, 4 years of degree, after that, all your degree certificates will be authenticated by the SRM University COE, and it will be available in a digital manner. So that if you go to abroad, your degree certificate has to be verified, it can be digitally done. So all this is done for this purpose only. And also all of a birth certificate, death certificate is all digitally signed and then available online. Anytime if you want, you can give your date of birth or in case of a death certificate, the date of death of a person to retrieve back the certificates. So these certificates contain their identity credential in order to be recognized and trusted online. So CAs play a critical role in today's digital age because they build a trust relationship between different business partners online, encrypt business transactions, and secure the communications between the different parties conducting e-commerce transactions also. So let us see the scenario I have told for individuals, right? And for websites, what are the analogy? So in case of a digital certificate for individual, it's like a passport. So once you can use it within your country to verify your identity. Similarly, if you are in United States and your passport is issued from New York, you can safely use it in Washington, right? The local authorities in Washington will recognize and trust your personal information because your passport is issued by a government agency. They trust the New York authorities. If you moved outside United States or foreign countries that accept US passports, will also verify. But apart from that, your verification will not happen. So within that particular area, wherever digitally this passports can be used, will be accepted. Otherwise, it won't be accepted. Wherever your CA is recognized, it will be accepted. Analogy for online services. For any online transaction, digital certificates are small data files that contain identifying information such as security issuer, public key, hold name, expiration date, serial number, version, certificate issuer digital signature, and other information according to each CA provider. Then only online services are authenticated. So we are doing massive online transactions, right? Behind the screen, this is what is happening. This is not there. All our data, whatever we are accessing a website, and then we are going for Amazon massive product or Miso app. So many apps we are using, right? And we are doing the online payment also. For all these things, the digital certificate is very, very, very important. So the certificate enables its holder to bind of a public key to him or her, example the website, and the digital certificate encrypts the connections between the communication parties to ensure secure exchange of confidential information online. And it also lists what actions its holder can do and what actions the holder cannot. All these are listed. So via which certificate authorities can be able to provide us the online services. And lastly, analogy for website. Every website, what we are logging in and using it out, every website, it will be having a SSL certificate like this. For example, I have shown here about the LinkedIn.com issued by DigiCert Inc. Corporation, right? So I have shown up here. So it's popular digital certificate is the SSL certificate issued for the websites. Secure socket layer, that's a certificate. So SSL binds ownership details of a web server to their cryptographic keys. So these keys are used, if you could see here, they've used SHA-256 fingerprint. That's the key used. So these keys are used to establish a secure session between the child client's browser and the web server hosting the SSL certificate. So these are the applications of your CA certificate authority. So the most commonly used, what is the standard used is X.509 format. This is the International Telecommunication Union Telecommunication Standardization Structure, ITUT recommendation. That's what is X.509 is the format. It uses PKI, which is a public key infrastructure. So the information in an X.509 certificate includes version, serial number, algorithm information, issuer name, expire date, subject name, subject public key, and optional standard extensions. So many SSL certificates follow this standard format only. Cryptographic key pair using GPG4W. It's for Windows basically. Privacy guard. BG represents privacy guard. G represents GNU. GNU is basically as a Linux based operating system. It's a kind of that software. So this GPG4 enables users to securely transport the emails and files with the help of encryption and digital signature. It also supports both this pretty good privacy protocol, OpenPGP, and SPAR-MIME. So what is SPAR-MIME? Is Secure Multi-Purpose Internet Mail Extension, which is a security standard used to encrypt and digitally sign email messages to ensure confidentiality, integrity, authentication, and non-repudiation, which are the basic cryptographic functions. So it works together with X.509 certificate, which provides a cryptographic identity needed for secure communication. So basically, SPAR-MIME is an email security protocol uses public key cryptography based on X.509 digital certificate. Especially when we are sending an email, we try to attach many files, right? All this will be verified using this only. So GPG is here, GNU Privacy Guard, where GNU is it's like an operating system, Linux based operating system software. So a cryptographic key pair using GPG4 is basically not a program by itself. Rather, it is a suite for 5 utilities. What are the 5 utilities? Are bundled together as a package, right? The first one is the GNU-PG. I already told you GPG means GNU-PG, which is your Linux-based operating system privacy guard. It's the core encryption tool. Then Cleopatra, which is a certificate manager, right? GPA, and an alternative certificate manager for OpenPGP and X.509, and GPG-OL, which is especially for Outlook Express, extension for Outlook Express, because Microsoft supports for 2003 till date, it supports for 32-bit and 64-bit versions. Everywhere it supports the Microsoft Outlook, where you know very well that email can be shared upon it. And lastly, GPG extension, a plugin for Windows Explorer to provide file encryption. So GPGX is especially extension for Windows Explorer. So thank you. This is what I'm trying to cover here in the session. So I have introduced what is the various cryptographic system trust model, which is your Web of Trust, Kerberos, and Certification Authority. All this will be useful for creating the cryptographic systems. Thank you once again. Thank you.